Good day. My name is Mikhail Popov. I am a senior scientist at RISE, Research Institute of Sweden, and with my colleagues Alex Jonsson, also from RISE, Barry Brown, Moira Drummond McGregor from Stockholm University, as well as Marco Moletta, Matteo Tatiela, and Sarah Noshkova from Flops Robotics. We are going to tell about our project, which is about autonomous drones with computer vision for tracking and management of wild stock. The idea is to use drones flying autonomously and patrolling the area and keeping track on animals, identify these animals using the artificial intelligence algorithms, and send this data to user interface and mobile user interface, for example, and where you can have information nearly real time and about the type of animals, as well as snippets of the videos if necessary, so that you can keep track on the movement of the animals in particular, as well as to have historical data where the animals have moved. The idea is to infer to process the video stream directly on the drone and make identification directly on the drone. And here's a video showing how it's done. As you can see that each animal is identified separately, and the algorithm is trained to identify people too. It will be important later. Different kinds of animals, including deers, wild hogs, also tracking the animal as it moves, putting a label on an animal, and keeping a track on the flock. The drones are also equipped with an ultrasound repeller. Here you see in the offline tests of it when the repeller has been mounted on a tower, so during the night, and it's possible to hear the sound it makes. It's a really high pitched, and there is a similar test done during the late night, and here you can see, so as soon as the device is turned on, the wild hogs are scared away. The drone is supposed to be not alone. It can be a whole fleet of drones which are managed by a drone management system, so that one operator can control many drones which exist in many different locations and receive and process information from them. The vision is that the drones, which can be airborne about 30 minutes on average, they will be able to automatically land down and recharge. There is a concept picture and a construction picture of a charging station where the drones will be recharged. And if there you have few drones, then you can maintain the operation constantly without intermission, and so the drones can patrol the area continuously. It is important to, as exactly as possible, identify the animals, because this will give insights on which specific areas, which specific weather, depending on the application. So if the application is to scare off, that you do scare different animals, but it might require like some extra attention if, for example, we're talking about wild hogs or different kinds of deers. People in the picture can also happen that people manage to appear on the pictures, and it's important that the idea to meet the GDPR regulation, the idea is to exclude them directly on the drone. So the algorithm basically blurs the detected humans or removes them completely directly on the drone. And if it happens that the people, images of the people sneak into the database anyway, the extra measure can be that you process them additionally on the database. So basically, people are removed. Their main images of the people are removed already in the database, so that the compliance to GDPR is fulfilled. And the identification, it can work, as you can see, both during the night using the infrared camera and using also during the day using the RGB, regular RGB camera. So by the end of the project, it is expected that we have a complete and autonomous system with drones which can lift from the ground, patrol the area in the simplest implementation, following a certain route, and they will perform detection automatically on the drone, and we'll send the snapshots and short videos if necessary, together with the identification to the management system, to the system on the ground, where the operator can see exactly what kind of animals present where. And it's the management system allows to operate many drones at the same time, and the drones are eventually will be able to recharge themselves on the ground, and at the same location they can be a number of drones, so they can patrol without intermission. The drones are not yet, but eventually will be equipped with the ultrasound repellers, so the drones will be able to repel the animals themselves. So the project aims to perform 2 full-scale trials in 2 different locations, and the complete system to be tested, so it can collect data, analyze the data, get insights, and collect it at the user terminal. There are certain questions which are not answered, like it is yet to be tested whether the system will be able in more extreme conditions when it's raining or too windy. And also the visualization itself, depending on the application, can be tailored, because in some cases it requires documentation of the animals being visited some certain place at a certain time, and apart from repelling the animals, or the animals using the ultrasound repeller can be repelled instantaneously. Another important part of the project is compliance. The compliance Europe-wide, and also been overseas in the United States, and that's a part of the project as well. The project also looks at a business model which can be suitable for different applications, and for farmers, on the authorities taking care about nature. And as it looks now, it is a subscription-based model, and with 1 drone covering about 200 hectares. Here are our contacts. We are still looking for potential sites for tests and use cases. So thank you very much for your attention, and have a nice day.